So, next up is our wonderful speaker. We have flown in from San Francisco, just arrived, a bit jet lagged, and I'm really having a hard time pronouncing your name, so could you pronounce it?
It's Guillermo if you are in Argentina, otherwise Guillermo if you're anywhere else. But now you know both, so that's good.
So you probably know this guy. He wrote a library called Socket.io to do.
Woo!
But I don't think you will talk about Socket.io today, but you will talk about
a little bit
reactive interfaces, which is part of following along with the Ember and those kind of things. I'm quite curious to hear what you have to say. Let's give him a hand.
So I was just telling him how it's really good that the previous talk was about usability and user experience and accessibility, and also about when should we use JavaScript, when we shouldn't, because I'm going to talk also about those things, but from the perspective of performance and how it impacts whether you render on the server, you render on the client, what happens once you go with the idea that you're going to render all your pages and control your history with client-side JavaScript. So I'm going to tell you what things you shouldn't be doing, what things you should be doing, and what things maybe you don't realize that you're doing, but you can correct them. One of those things that you shouldn't do is upgrade to Yosemite right before a presentation. So the top bar looks really nice, but what happens is Keynote just doesn't launch unless I go to Show Package Contents. All right, ready? Contents, Mac OS, and then you launch the script, which launches a terminal, and then you have it. And then you can only open it from File Open Recent. It's wonderful. But there it is. All right, so I'm going to talk about 7 principles, 7 being completely arbitrary, but it's pretty close to all the things that I think you should be keeping in mind when building not just websites, but applications. But also I'll talk about how those two are not that different in many cases. I think user experience is what's driving all the innovation in what we're doing every day, including real-time communication and WebSocket and frameworks. So it's the lens by which we're going to look at all of these principles today. I think it's more important to keep in mind user experience and languages than patterns or MVC or Flux or React or whatever it is. And also hashtags. Don't be driven by hashtags, it's bad. So I'm going to talk about how, to me, JavaScript is a means to the best user experience. And I think that in the transition towards using JavaScript for everything, for driving all the interaction on the front end, we've broken a lot of the principles that made the web. And not just broke, but significantly, I think, destroyed it. Like we took the web and it was just, take that web. So part of those things that we do is we render blank pages. We broke the idea of scraping. So there used to be a web that was based on this idea that anyone could access it with just implementing HTTP, get some HTML, and with that HTML would come the content, and which also happened to be extremely useful for testability. So it's a lot easier to get some HTML or assert the presence of some data that you're expecting with an HTML response than it is to launch a browser that runs a JavaScript virtual machine. And in a lot of cases, just as another example, we broke the back button really badly. The browsers came with a really simple model by which history worked, and in the transition to single-page JavaScript applications, we broke it. And also, once we switched to this new model where all the interaction and all the behavior of the page or the application is driven by JavaScript, some new opportunities and responsibilities came up that we missed. So for example, a quick test that I like to run on applications is if we assume that, for example, you open a socket and you're getting real-time updates, what happens when the connection is not ideal, or when a lot of reconnections happen in succession, or what happens if you close your laptop and resume that session a week later? Is the page going to reconciliate with the latest data known to the server? Or even run the new code that you might have released in between? Another great example is, in a lot of cases, you make changes to your backend, and your front end now is outdated. Since people are not constantly refreshing and getting the new scripts and styles from the server, you might even introduce interactions that are completely broken. So for example, something that changed on backend API now doesn't really work with the front-end code that was loaded by certain users, so you need to update it. And like I said earlier, I think there's a lot of new opportunities that we're not taking advantage of. In a lot of cases, we use this technology just to get maybe a few interactions to make them faster, but we're not fully taking advantage of all the new possibilities that it creates. So I'm going to try to summarize all of these things into 7 principles. The first one being, I think server rendering is not a choice. I think in a lot of cases we're creating applications that, for example, rely on tricks for getting rid of the backend. So, for example, we use the hash for location that drives the page interaction, or in a lot of cases we also launch a blank page that loads a script tag, and then the interaction with the page begins. So I found in my experience building a lot of JavaScript applications that we've set up a false dichotomy. In a lot of cases, we're discussing whether it's better to build an application that renders HTML on the server versus one that, for example, uses a router on the client and an MVC paradigm, and we sort of like set them up in opposition. But what I found is that the best way to do it is actually with a hybrid application. And if there's one takeaway from this presentation, it should be that you shouldn't render ever. There's no good reason to render a blank page that then makes the user go again to the server and fetch a script, then interpret that script, and then render something. And in many cases, that script also requests more data from the server to actually render something. So the driving principle of user experience in this case is that we want our applications to be as fast as possible, specifically in enabling the user to get what they want. Nat was saying how, for example, if you're opening a tweet, there is enough information in the URL that the server has an opportunity to render exactly what the user is after. If we, for example, switch to a single-page application that loads the scripts for all the possible interactions that the user could do under that particular domain, we're missing a great opportunity to be fast. And the reason that is even more important, and the reason that I said we don't have a choice, is that the way that we send data back and forth from the client and server has some fundamental limitations. And I'd like to start by, for example, stating what it, like to put into perspective what it takes to send a packet from coast to coast in the US. I took this example from the web where the distance from, for example, the University of Stanford to MIT was about 4,000 kilometers. Then he goes on to calculate the speed of light in the vacuum, but that considers the friction that the speed of light has when the fiber is how we get packets from coast to coast. And that turns out to be 66%, so there's a loss of potential speed there as well. And then he talks about how calculating the back and forth of that packet would be approximately, in a theoretical way, the lowest possible amount of time that it could take is 43 milliseconds, which is actually, if you think about it, pretty substantial. And then he goes on to actually test this and finds out that with the architecture that we have at the time, it's actually a factor of 2 times the theoretical minimum. So getting a packet from coast to coast takes about 85 milliseconds. If you, for example, launched an instance of your server and you're hosting everything in San Francisco, you have to assume that there is already a significant delay for people to get the data from their coast that you can actually do nothing about. There's nothing you can do to lower this other than finding something faster than the speed of light or changing the entire architecture of the internet. So this comes from a great talk that's actually titled, "Is the Latency Stupid?" Because what the author wants to point to is that in a lot of cases we obsess over bandwidth, but we don't consider latency, which is actually the bigger enemy. From this lens, I think the conclusion that we come to is that we have to minimize round trips as much as possible, because there's nothing we can do about how long this is going to take. Surely you can make the servers be closer to the user, but maybe that server still needs to talk to another server way in the other part of the world, and there's nothing you can do about that. So other than minimizing round trips, in order to become really fast, you now can understand why rendering something that implies a lot of round trips just to start processing the data or requesting some data from the server is not only slow, it's really sad and makes me cry. So the other side of this coin is that in many cases these script bundles are so big that if you consider the packet size of the TCP connection, it's actually going to take a lot of round trips just to complete the script, which of course needs to be downloaded completely before it can be interpreted as valid code. And if we also consider how the underlying technology works, which in this case is TCP, is what's the mechanism that's delivering this script, we have to understand that it works in such a way that the initial phase of the connection, which is that first click that you make to like consume some data, for example, is actually the slowest. There's a congestion control mechanism in place. It's called a slow start. And it's in place and it's slow on purpose because the server and client need to agree on how much data they can exchange. The server needs to avoid congestion, and the client needs to be able to consume the data that the server is trying to send. And the way it works, there's a great presentation that Paul Irish gave called Delivering the Goods that sort of tries to answer the question of how many HTTP requests is too many HTTP requests, which has sort of been a black box up until this presentation at least. One way to look at it is the server is only allowed to send 4 segments in the beginning, and then 8, and then so on until it gets to the exponential phase, and that's how you can start like loading the scripts as fast as both connections allow in most cases. So from this reality, which actually looks a lot worse when you're on 3G, so it takes about 300 milliseconds in the best case scenario to get to the 8-segment time. We sort of conclude that the first 14 kilobytes are the ones that are like the make or break. If you're not doing anything meaningful in those 14 kilobytes, then it's a hugely missed opportunity. So one thing I've observed over time, because I think for some of us that have been working with JavaScript for so long, there's always been a healthy amount of debate on should we do everything on the server, should we do everything on the client, should we do a hybrid. There's always been the people that have created such fast server-rendered applications, not even just websites, that I think they've put forward that JS is not needed on the client, or that in many cases it just bloats or ends up making those initial load times a lot slower. So what I've noticed myself is that if you have a really fast backend, and then that backend happens to be located near the user, and what I mean by fast backend is, for example, one that's able to get all the data to render the page very quickly. In many cases, in order to render the entire page, it's useful to create a client-side application because you can fetch data in parallel. But now let's assume a server that's actually has very low latency with the own web services or databases it talks to. Then you place that near the user, and then you also do something really meaningful in that initial 14 kilobytes, like for example, not introducing huge blocking style sheets and only rendering the styles that matter for that page, or the ones that are structural. An example in the previous presentation was that in many cases, even the default browser style sheet is good enough. In other cases, I found that delivering just a structural CSS is good because it keeps you within that limit, and then you can lazy load the parts of CSS that are not relevant to at least satisfying that initial window. So if you do all of the above and you're still not using JavaScript, it might seem like JavaScript is unneeded because the interactions are going to be so fast. This example that I really love is Stack Overflow in actually 4 kilobytes. It does use JavaScript, but he managed to include all the JavaScript and all the CSS, and he inlined the images as base64, all in 4K, and the entire website works with all the sections like users and tags and questions. So here's an example of everything he did. Obviously, it's a little bit extreme. He manually minified code and things like that, but it shows that if you're able to make a website like this, it doesn't really matter what you're doing and where, because you're satisfying that initial window, you're minimizing round trips, and the result is actually an application that works really well and is really fast to load initially. So you can check it out on that link. So I was recently on Twitter. I spent a lot of time there, just kidding. And someone from the Google Chrome team tweeted out a really amazing discussion that happened when the image tag was introduced to the web. You would think that the image tag was born with the web. I wasn't there, but I'm surprised I wasn't. In 1997, Mark Andreessen, the creator of Mosaic and Netscape, emails the list where Tim Berners-Lee and all those cool people that invented the web were hanging out, and he proposes the creation of a tag for rendering images. So my interest peaked with this mailing list discussion because not just because of the historical reasons, but also because it turned into a huge bike shed discussion where they went back and forth on creating meta tags that would not just render images, but would render embedded documents. Because first you need images, and then you're going to need sounds. Someone literally says that on the discussion, even though sounds were added with the audio tag like 20 years later. But a great quote that's part of that discussion of they were trying to make anchors embed documents so that when you would render the page, it would parse, it would see that there's anchors that are trying to embed another document, and then it would render the page. So Mark Andreessen's comeback is actually really interesting because he says that if you start doing this like multi-level approach to rendering HTML, you're going to break the single hop principle of the web. And when I was mentioning that we destroy the web, I'm talking about this in particular. The web was ideated in situations of, well, of course, really high latency and low computing power compared to today, but there was this really amazing idea that you would be able to deliver all the content at once. And that's what he refers to here as single hop. My main idea with principle one is try to get close to doing something meaningful in that single hop, specifically those initial segments. The next principle is what my presentation is actually titled after, which is the idea of input reaction that triggers some sort of optimistic rendering or layout adaptation. So this is one of the new opportunities, of course, that comes once everything is good and you're ready to load JavaScript. The main idea here is that at some point we're never going to be able to reduce latency beyond what the network allows. If the user is, for example, on airline Wi-Fi or really bad 3G connections, there's nothing we can do between server and client to make that packet go faster. But JavaScript creates a unique opportunity of masking latency altogether. And this is why I think also including JavaScript on the client side is not a choice, unless, of course, you want to leave the perception of its speed up to the network. So that's the main idea, basically. We can capture input from any of the ways that the user can do it, with their mouse, with their keyboard, with touch screen, and then react to it immediately without hitting the network. One of the opportunities here is what I call layout adaptation, which is done by Google. So when you start typing something, as soon as the key down event fires, they adapt the layout to what's going to be eventually. So they know that if you're searching something, you want to see results. So as soon as you type, even though the network hasn't come back with a response, they adapt the layout to what's going to be eventually. And this is a very powerful thing when it comes to masking latency, because of course you're not waiting for that reaction. This is where rendering only on the server would be naive, because you would have to wait until one of the mechanisms that the browser has built into sending data, which is submitting the form, which goes and requests an entire new page. Another great example of layout adaptation is Facebook. So when you load Facebook, even though they haven't gotten their data, they will render what your newsfeed is eventually going to look like. In their case, it's very interesting because when I talk about server rendering, I don't necessarily mean that you have to render everything. In a lot of cases, parallelizing the request on the client side is also hugely useful. In this case, for example, it would make sense to prioritize the newsfeed load over ads or vice versa, depending on who you ask. Another great example that I like in terms of optimistic rendering and layout adaptation is Pinterest, which does an even better job than Facebook because they rendered the layout to the size it's going to be once the image loads. So there's no changes in height or jumps when the content finally comes. And also, they have pre-computed the color average of the photo. So those photos, once they load, one is actually brownish and the other one is actually orangish. I'm just making up those words. But the idea is solid. Go Pinterest. I had to create an account for Pinterest. I've never been on Pinterest, but they've done a really good job. And a great example also of layout adaptation is the iPhone version 1, which due to their low power and low CPU capabilities, they would ask users to pre-populate their apps with an image called default.png that would look like what the app would look like once it's actually rendered. So in this case, it's also masking latency, but it's masking CPU latency because the phone was kind of slow. But we all bought one for $800. The other one that's really interesting to me is another form of input that we can react immediately to. And I think this one is actually one of the most frequently overlooked ones. Like any website that has to do anything with files, they should be taking advantage of this. So any time we detect the user's intent to upload, which can happen in a variety of ways, it can be drag and drop that carries files information within the event, or it could be copy and paste for browsers that support it, like Chrome, or it could simply be that you introduce an input file picker. We have an opportunity to load that file with cutting-edge JavaScript HTML5 technologies and render it. And going a little bit beyond that, we can even analyze the file. So in a lot of cases, rendering means pre-processing or conversion. But a lot of files, it's pretty standard that media files, for example, have EXIF metadata, which we can read. And in a lot of cases, also, it contains a thumbnail, a very small JPEG thumbnail, that we can also extract from that file and render it right away. So even files that we can't render directly with our browser capabilities today, we can analyze the EXIF information and extract the thumbnail from it. We do this at my company for files like PSDs, for example. So they contain a JPEG inside them, so we don't have to actually render a PSD. So another example is producing thumbnails on the front end. And this will come to be important also for another principle, which is deciding how we precisely send data from the client to the server. In a lot of cases, JavaScript allows us to also compress that data. In the case of images, it's sometimes useful to produce a thumbnail on the client side to avoid sending very, very large images, or doing it in a step-by-step way. Something we do, for example, is on CloudUp, when you first drag and drop the image, first we use the object URL API to render the image right away. It's faded out to give you the idea that it's not there yet, but the reaction is immediate. We don't wait until the upload is complete. Another thing we do is we produce a thumbnail in a web worker that we send right away with the initial request. So for people that are on the receiving end of this, they can start consuming the information as soon as we can express intent to the server that someone is sharing something. And eventually we send the whole thing. And again, in this case, you're gaining perception of speed, but specifically when it comes to file uploads, which are normally considered to take a long time and users hate it. So any sort of like preemptive rendering that you can do is going to help a lot this perception of speed, that it's directly tied into the satisfaction of your users. And speaking of satisfaction, somewhere where I'm constantly dissatisfied is airports. But the fine people at the Houston airport, and I stole this example from a talk from Steve Souders from Google. He talks about how it used to take a long time at baggage claim at the Houston airport, and there was nothing they can do, sort of like, we can't do anything about TCP yet. There was nothing they could do about making the process of taking the bags out of the plane and putting them on that lane faster. So what they did is they increased the walk from the moment you leave the plane to this little place by 6 times. If it takes you 6 times longer to walk, then you feel like the airport got faster, and that's what we can do as well. I do this too for removing spinners from my websites and web applications. Of course, there are situations in which doing all of this optimistic rendering can actually be dangerous. For example, processing payments. I can use some cutting-edge JavaScript code to tell you the payment is processed, but then it's not, and then you get evicted from your apartment or something like that. So, of course, there are situations in which you don't have to fake it all the way, and it's important to get the right amount of confirmation from the network all the way down to the user experience. So another great example is logging out. We can actually tell you that you're logged out right away, but maybe it fails, and 5 minutes later, someone is using your session. It's happened a lot recently. But even in that case, I found that spinners should be extremely rare. So that's sort of like a side note of this principle. There's a great opportunity for deferring the display of anything that's taking a long time, because it's actually hard to define how fast is fast enough or how fast is immediate. Does it vary from person to person? So the advice that I like to stick to is the one that I think was quoted by Nielsen frequently, which he claims has been the same for a lot of time in the study of human-computer interaction. Some of the conclusions are that 0.1 second is how fast people need a reaction to feel like they're operating directly on the data. And the example that I think about when I think about this is spreadsheets, where there's no latency between selecting a cell and typing and like the idea that you're persisting the data. 1 second is the limit at which the user feels it's instant. And this is why I like deferring my loading indicators or spinners to the future, because if it's under 1 second, sometimes you seeing a spinner flicker or seeing some loading text that makes no sense, no special feedback was actually necessary, and the user was still feeling like they were operating in real time. And 10 seconds is about the limit. It's where people actually will go to some other website or check their phones or their Google Glass. Not that anyone uses Google Glass, though. So yeah, like I said, this advice comes from 1993. It's pretty cool. Principle 3 is one of my favorites and is the reason why I think you all should use Socket.io. It's the idea of reactivity, or what I also like to call a UI that's eventually consistent. So for example, if you have many tabs open of your application, they should all be consistent with regards to the data that was on the server. And in order to do this, the front end has to be designed in such a way that it reacts to data changes. So once you load some state from the server, you have to be expecting new changes to be coming and adapt your front end code appropriately. And this has become, I think, crucially important as of late, because in a lot of cases we're interacting with the same data set from many different devices all at once. Like you take a photo from your phone, but you expect to see it on your computer right away, or you're chatting with someone, but in order to take a photo that you want to share with that person, use the mobile app for that particular website you were looking at. So if the data points are increasing because the computers that we carry are increasing and the amount of time that we spend on the internet, on Reddit, is increasing, then we have to be even more conscious of reactive interfaces. And as far as CloudUp goes, the example where we found that this made a lot of sense was actually the idea of pushing uploads. Instead of things going into a sync queue where like you don't know how fast they're going to get to your computer, we give you the possibility of just pushing them directly. So if you're using your phone, you see how like the UIs are consistent between each other as far as the data on the server, and everything is constantly being sent. We try to avoid even having save buttons and things like that. So one of the responsibilities that comes from assuming reactivity is that you have to do it all the way. You can't do it for just a subset of the data, because I think that introduces confusion. And a new opportunity in that regard is also the idea that if you log out from a tab, and you had other instances of the application active, you will be logged out of all of them. So it even enhances privacy, whereas the current web wouldn't do that because it works with snapshots of data that by themselves they don't refresh. So as far as session synchronicity, here I have two applications open for Cloud App, and when I log into one, if the session was active somewhere else, it's also going to be logged in. And that goes for every single view, because some views have a layout, like in this case, that's for the logged out state, and a layout that's for the logged in state. So you have to consider what every page would look like in the context of session switches or logging out. Another, and I think, like I was mentioning earlier, a responsibility that comes from implementing reactivity of any sort of like real-time newsfeed or things like that is the idea of state reconciliation. To begin with, I found that a lot of applications don't handle reconnections well enough, specifically around failures and specifically about retrying when data fails to send. A test that I like to run is I close my laptop with an application that updates in real time. What happens when you are offline for a long enough time that it's not feasible to buffer, either on the server or on some database, events about how the data changed, that then you can send them all at once to the UI. So what happens usually is that you reopen or resume that session, and two things can happen. One is the delta of information is so big that it's not handled appropriately. For example, if you were looking at a news feed and you're offline, you come back online and 2 months later, of course you don't want to see the entire delta. So that's one of the things to consider. This is fictional. I edited it with Web Inspector. It was like 120 tweets. Yeah. So that's one of the possibilities. Another one is that altogether it doesn't handle it, which is even worse. And if we go by principle one, which said that we're also rendering data on the server, and then you're sending that over the wire to the client, it's even more important to handle reconnection, because what happened right then is a disconnection. Essentially, when the HTML is on the wire and it's getting to the user, and the user then loads some JavaScript that opens a socket, the data might have changed. That's why you have to always be mindful of your app being able to reconciliate state of the past with the very latest. Also important is the idea that we now have the ability to decide exactly how we're going to send data from the client to the server. And traditionally, I think browsers did a really good job at creating a very simple system for doing so. So there were three basic ways that you could send data from an active website to a server. One was you would click around, that would trigger a GET request, get some HTML, introduce a new history entry with the new page. Another way, and this was really bad, you would fill out a form, press post. That would also result in some HTML. It would introduce a new history change to a new page with the URL matching the post. And then if you press back, it warns you that you're resending the data. It was wonderful. And then another way was embedding things. So if you embedded an image, that will also request data from a server and try to render it somehow. And this was limited, but it gave us a good mental model to go by of how history works, or when data is being requested, or when things are being rendered. The first hack that I can recall that came to sort of break out of this model and introduce new ways of sending data from the client to the server was introducing little images that were hidden to the user. I would say that this was like prehistorical Ajax. And it came usually in the form of tracking the user with Perl CGI bin scripts. Not sure it was Perl CGI bin, but I think so. Another way that we could send data from the client to the server right after this was right after the first few iterations of JavaScript in the DOM level 0, we could create an image and set the source to some script. So even though we weren't going to eventually render it, it was a new way of being able to send data from the client to the server. And funny enough, when some of the first versions of Facebook surfaced, a lot of the things you would hover would have an inline script on hover, new image, and they would use this for tracking. Because actually this happens to be, even to today, the shortest way that you can generate an asynchronous request to a server. Fun fact. So after that came iframes, and basically the idea of also, once again, hiding them. But in this case, we had a lot more flexibility because we could inject the iframe, do something inside, then that could result in loading a page that has a script tag that communicates to the outside. And this was basically what we had before then Xmlhttprequest and Ajax came about, also with ActiveX object for Microsoft. Then Xmlhttprequest evolved with version 2. It got new features. So then not only could we send just simple XML or JSON or text, but also binary data. Also, it introduced the idea that you could stream data from the server. And then the next thing we got in terms of client-server interaction was server-send events and a WebSocket. So with all those things in mind, we have to keep in mind that we now have to be mindful that when we establish a real-time connection, either with server-send events or WebSocket or whatever it is, the user needs to know that what the state of the connection is. For example, when reactivity is expected, the user might think that the data that they're looking at is last known to the server, but maybe you have detected a disconnection or a timeout, and it's a new responsibility to notify the user. And the way that most websites or applications do this by now is they try to detect a threshold by which they haven't heard from the server. They will consider the socket disconnected, and then they will try to do some exponential backoff. So you will also have to notify the user that you're going to reconnect sometime in the future. And the opportunity that comes with this complete control over how the client can send data to the server is offline support and the idea of synchronizing data, not just sending data in basically to a stateless HTTP endpoint. So for example, even if you're disconnected, you can still allow the user to go through with their intended input, put it in local storage, and then take advantage of the possibility of syncing it later back to the server. And a new API that's extremely interesting to enable this is Service Worker, because we're going to be able to sync data even when the tabs are not open. So Service Worker introduces a long-running piece of JavaScript that comes with your page, but it's actually running even after all your instances of your page have closed. Another opportunity is the idea of also trying to not show, just like we're trying to not show people spinners, we can also try to not show people errors, especially if we deem that these errors are transitory. When such cases, for example, a temporary error 500, we should try to do it a few more times before we give up on that, and basically retry on behalf of the user. Upon connection loss and immediate reconnection, we should also try to sync messages on behalf of the user and notify them in the UI of such. And like I was mentioning, it's extremely important that if your rendering is optimistic, you have to have in mind that you're going to have to sync and inform the user of potential errors. No matter how fast your chat application could be, or how fast the network is, most applications end up rendering your chat message as soon as you press enter. But the message actually is not on the server yet. So since it has to be synced later, you have to even keep in mind potentially asynchronous error notification mechanisms. For example, you say something and you close the chat window and then an error occurs. How do you notify the user of something that was happening on the background? Finally, something along the lines of controlling the entire connection from the client to the server is detecting that something might have disabled the user from being able to perform a certain action. For example, that could be a case if from another part of the infrastructure, you time out the user's session and now the response from the server to some of your Ajax endpoints is 403, you have to be able to handle this so that you can trigger the logout view immediately, or ask the user to keep their session active or try to renew it. And if you do all of this, including the ability to sync once you've rendered something optimistically, you will need to keep in mind that there's a chance that the user might try to close or tab while data is being sent to the server, and potentially, for example, not getting a confirmation that something that he intended to do actually happened. And such case happens, for example, in Gmail, where when you try to navigate away after sending an email, even though they say, we're sending, don't close the window, and you do it anyways, you will get an on before unload event handler to tell you that data is being sent to the server. So any single page application that you create in this way has to handle this situation. You have to notify the user that they are at risk of their data being not confirmed by the server. And another way of doing this is also in a much neater way. If you have outbound links, you can choose to, for example, open them with target blank, or you can choose to notify the user that they're going to leave the page, but using your own UI, because you know what the browser, you know that the browser is going to give up on the current window and the current state, so you can interrupt outbound links or form submissions to render your own version of this dialog. This one is a principle that I take a lot of issue with a lot of client-side driven applications, which is the idea that we broke the back button or we made it worse. One of the new opportunities that we have is that just like we're reacting immediately to all sorts of input, like entering text or clicking something so that we render another page right away, we can also do it when they press back. And a way of doing this is you cache the state of the page as it is, and once you make a transition via push state, when you detect that the user is trying to go back, you can render that HTML that was pre-cached immediately. So in that case, you improve upon the default behavior of the browser, which in many cases it's to make another request to the server. So when you press back, and the user in that case expects to see some reaction immediately, maybe some data that they were looking at just now, instead you give them basically a long transition. So by caching the HTML and performing that fast back, you improve the experience a lot. And also, this requires thinking about relative state changes. So for example, if you're looking at a newsfeed and you scroll down and you click on something and then you press back, that's different from, for example, go to the URL directly through a link. In the former case, you want to preserve, for example, scrolling, and you want to react immediately. In the other case, you might want to do, for example, what Facebook does, which is render a placeholder again to give you the idea that they're getting the data. And the problem that I've seen is that a lot of frameworks, the problem that I've seen to cause this to be broken is that a lot of frameworks treat the router as one thing that's absolute, and that's how you structure your application. And they don't think of routes as decorations in many cases. So what happens is, no matter where the state change comes from, or if it was relative or absolute, they will trigger a repaint as if it was a brand new page. And they can't take advantage of this optimization at all. So as a side effect of that as well is the fact that you have to maintain scrolling memory. And this is especially useful when you have infinite loading UIs. Normally, the browser does a really good job at handling this if we consider that JavaScript is not in place at all. So for example, if we try to do an infinite loading thing with regular server-rendered HTML, you would have 10 entries. At the very bottom, you would say load more. That would introduce a new page state with a new URL. And then you click on something there, and then you press back, and you're exactly where you want it to be. But ever since we introduced super cool Ajax, we've broken this a lot. A counterexample is Twitter. I'm really picking on Twitter, but I love the service. If anyone works for Twitter here, I love you. So this is a quick example of precisely infinite loading that breaks scrollback memory. I go to a tweet, I press back, I'm somewhere else. And for a moment, I was on that same page. It's really bad. And I saw a spinner at the very top. Let's look at that again. So it was broken all around. And that's a side effect, I think, of some of the things I mentioned. For example, like treating your router as something that's absolute. So that's why you see the spinner again, because they're probably thinking that, oh, we have to render this entire page again. So keep that in mind, please, especially if you're building a newsfeed. Another important thing is to consider local transient state that might be relevant only when the user is using back and forward buttons. So there's changes that you do on the UI that are only relevant to that one instance of that one page that you were working on, are not meant to be persisted to the server, are not meant to be remembered, but you do want to remember them when you're going back and forth. Counter example again, Reddit, you're on the pictures subreddit doing work, and you look at this photo, and then you press back. So far, so good. Scroll back, not so good. You go to comments, and you collapse a few trolls. And then you go to the image again, then you come back, boom, collapsing is gone. And that happens throughout all the history state interactions with this page. So the idea there would be that it's hugely useful to also capture those local state changes when you're scrolling back and forth. Principle 6 is one of the first that I mentioned in the beginning of the talk. If we assume that we're going to be using JavaScript on the front end, are we taking the measures to make sure that if your interface, for example, is reactive, there is no reason to close or refresh the tab at all, especially if you also handle reconnection. So something that's important to keep in mind is that those scripts are not going to refresh themselves. I've known from my own experience that I have Gmail open, for example, for months on a browser. Maybe months is an exaggeration, but definitely weeks. So applying all the other principles before this means that page reloads should be kind of infrequent. So code updates are a super important thing to keep in mind. And there's a few ways that you can do this. One is capture some sort of heuristic where it would make sense to perform a refresh. This is for applications that have not been thought up from the grounds up to handle dynamic code reloading. So for example, what you might want to do is detect a certain situation with the page visibility API that the page is not being looked at, there's no forms that are pre-filled, and that scrolling is in a certain way, and then you can trigger a full reload, and that would refresh the code. With this in mind, it's also important to notify the server what version of the code you're using. Something, for example, you can do is, if you're sending Ajax requests, you can append a header on each request that contains information about the code and what state it's in. So, for example, the Git revision number. This is useful for two things. One is the ability to invalidate responses from the server or requests. So, for example, you need new code to perform a certain action because of some security changes. What you can do is, from the certain client versions, you can respond with an error 500 or some error code or some header that indicates that the code needs to be refreshed. Another thing you can do is, if you're sending the information about what code's running, you can understand a lot better how your backend is behaving, and you can log that for later. So it happens to be extremely useful for that as well. And the way we did it back in the day was carrying an X version header. But a new opportunity that comes that I'm really excited about is hot code reloading. So if your application is written a certain way, it should be possible to reload the scripts without triggering an actual full reload. Specifically, I like using React.js because it enables, or it makes you get a lot closer to enabling this. The way that React works is that you're actually caring a lot about some state changes that happen to components. If those components have no side effects, and React is merely repainting the page every time the state changes, it should be possible to change the script and basically make this act as if it was a full reload, but without requesting style sheets if they're not needed, for example, or without making an entire round trip and full refresh and expensive repaints or redraws. And finally, once we've taken care of masking latency when we can do it, or we've taken care of optimizing our server and front code as much as possible, there's something that JavaScript enables us to do, which of course you can do with fully server rendered code, which is predicting behavior that actually hasn't happened yet. So a way of basically predicting user input is, for example, predicting that someone is going to click a button, so making a request to the server before the click actually happens. Facebook does this with hover events a lot, specifically when they're going to render pages that hit a lot of different backends. For example, the image lightboxes. Another way that Gmail used to do it is they would handle every click you would make, but by listening to the mouse down event and not to the click event. So that would actually mask the latency of releasing your mouse, which doesn't sound like a lot, but it could save you a minute in 2014 if you apply it today. Don't do it though, because a lot of people like holding and then, no, I'm not gonna go there. But the idea is that you wanna make that network request before the actual input actually happens and you can predict it. And on this note, something I've seen that I got really excited about is trajectory prediction. And I found this really good implementation where it sort of works like collision detection, where if at a certain angle and a certain speed, it's gonna detect that you're approaching a certain object that you're interested in. In this case, it can be used for two things. It can make your UI faster. In the example, this person triggers the pop-up, which effectively is a form of showing data faster to the user. But also you can do it for pre-caching data or preloading network requests. So if you follow all of this in this one talk, congratulations, you've built a unicorn. Thank you.
That was pretty spot on time. So we have a break coming up. Just have a slide here I want to show. So there's a break, as I said. This is cold front, so we thought you need something cold. So we actually had a special cold front ice cream made. I've been told that it's ready out there, so go out there and there's ice cream for you. Sorry? Yeah, that's the timer. I had that from yesterday with the artifact.